Hi friends, today we are going to discuss about TKPROF, that's a trace kernel profiler. Is a performance diagnostic tool which will help developers and DPA to analyze and perform to validate the performance of the SQL statement executed during any particular session. So using this tool, basically what you're going to achieve is like to identify the CPU time, elapsed time, and the disk or logical reads it's happening, and number of rows have been processed during that time in the particular session. Also check for any waiting events and timing. So the basic, predominantly the use cases to identify is the slow running query in any production or development course of time, like or any optimizing the query. So it will give the actual plan. With that, you can fix your SQL statement most optimal way and efficient way, whether it's going to full scan or whether it's reading the secret from the shared pool or something, and misses the cache. All those things we will identify those bottlenecks. We can get and get the TKPROF output file. It will give you more precise information. The alternative one, the general developers use the explain plan for seeing the any execution plan, how the optimizer handles behind the scene. But the problem is the execution plan, it will give the estimated plan, it will not give the actual plan information. Whereas TKPROF, it will give you the actual plan results, which will be very handy information for both developers and DPA. But initially, when you start using this TKPROF, what will happen? It will generate a raw generated file, which is not a human readable form. You have to convert. Then Because once you enable that SQL trace session, it will generate the trace file which is not human readable. Using the TKPROF utility provided by Oracle, we are going to convert as a human readable format. That is how it works actually. So the main objective, I'm going to give one use case like which I used it to demonstrate this TKPROF, is to trace the execution of on sample SQL query to generate an execution plan, how we are going to analyze and actually to get the actual performance results. Okay, the very firstmost step is identifying the default trace location. Okay, so to understand, when you enable that SQL trace session, so which location the file will be landing. For an example, if I run this query, select value from v dollar dialog underscore info, where name is equal to default trace file. So this is where in which you will find the path in which it's going to generate the file. Okay, so for an example, if I go back to this location, I already opened that location. If you see, so this is the path in which the trace files being uh, the trm file is the original file, and based on that file, sorry, the trace file, we are going to, sorry, trs SQL server profiler file, we are going to generate it. Based on that file, we are going to convert into txt readable form, okay, using the TKPROF utility. Okay, so that's the first thing. And the second thing, yeah, so to, as I mentioned in the beginning, like we have to enable the SQL trace property to true. For any SQL statement, you are going to generate a trace file. You have to enable before connecting to any user session. So in that session, you need to run this statement. After running that, I'm going to run this sample query as a third step. So select star from employees, where employee underscore ID one particular statement, a SQL statement. I'm just trying to, for demonstration purpose, I'm using it. Okay, so once I do finish that, we have to turn off the SQL tracing, so that in the current session, it generated file, so this similar to the files what we are seeing, this trace file location, you will see this file. Okay, the trace file will be the trm file, and trace file will be generating. You have to make use of this trace file to generate the human readable form as a following step. If you see here, once it is disabled, open like you need to locate the trace file. And for example, in this case, like I took this one example as a trace file, okay, the latest file. We need to we need to convert the trace file into human readable form, correct? So for that only, the actual TKPROF utility is being exercised now. So TKPROF followed by this trace file, what we recently for that particular session we identified, correct? That file we are using it, and the third parameter is the output human readable form, and explain is the property. We have different options is there, but here, so who's the user you're going to use it, so you have to give the fourth parameter. So explain connecting to which user, like okay. And this will create a output file. So from that file only, so for an example, I already opened the file. So this is how the file it will look like. If you see here, you will see the information, the trace file after the TKPROF utility. After running it, like this is how it will look like. See, for example, this is the query I ran it, and this is the actual plan information we are seeing here. What is the parse information, and execute information, and fetch information it will give, and what is the count, CPU information, time elapsed, and discrete is there, query and current session and number of rows, it is fetched, everything it will give it to you. Okay, so if I go back again, so how to read this TKPROF information, that's the next thing as part of the metrics. Okay, so the how, so in this particular thing we are missing the library cache during the pass one. So which what I mean by that is like this query, there is no bind variable being used, like it's hard coded. Select star from employees where employee id is equal to 100, which is not in the share pool, correct? Like, so it will miss the cache. So that time it will uh, it will go as a hard pass instead of the soft pass. When I say soft pass, if it is soft pass means it's already there in the share pool, it will not go for the hard pass and go and get from the buffer cache, right? So uh, so instead of the hard coded value, if you use it bind variable, it's a efficient method in this case. Okay, and the second, optimizer mode. So the optimizer mode which is using here, right, the down below, if you see here in the TKPROF output, so you see the optimizer all rows means the all rows which is represents the Oracle optimizing for the total throughput for the given query, right? So it is not the first set of rows it's considering, and the actual plan is it's not doing it. Instead of that, it's taking as a total throughput, it's considering using this optimizer mode all rows. Okay, this is for this optimizer mode, it will be really good for the batch or reporting queries in the large volume. So that's what the recommendation in general practice. Okay, and the followed by the execution plan summary, how to read the execution plan summary part of this uh, so this is the execution plan what you're seeing, correct? So here you see the table access by index row id employees. So if you see here, so it is using the index row ID and using the Unix index scan. So what does it represents? Like it's not using, since it's the cost is zero for index scan, because it's quickly getting the results, since we are using the index, and one for table access. The first one is this one for table access. It taking the for taking if you see here, the cost is 1, you see here. But whereas the cost for the index scan is 0, so that's what it represents. Okay, so cost for index scan is 0, but whereas for fetching the table access one, but still it's the best optimal result. And the input output operation, so input output operation, what does it represents is like how many physical reads. When we say physical reads, it does not have in the buffer, and it's going back to the disk and getting the results means, so that really costly thing. So but in this case we are getting zero physical reads, okay, which is means there is no disk operations involved. Instead it's taking from the memory. That's called two logical read as a consistent gates. And access path, so when you're talking about access path, it's using the index correctly, the what the index have been created under the employee table. So efficient way to get the access path in the faster manner, okay. And now getting back to the other section is planning section, plan section. So here in the plan section, so if you see here, so this plan section, how from the lower level, the bottom level, it will go to the top level. That's how we need to read it, like starting from the index mode and the table access and the select statement. So this is how the operation goes, correct. So if you see here, so index is this is already as I mentioned, we discussed in the before section, correct. So the execution details sections, right, like this is the plan section, gives the almost similar idea, like the index mode analyzed using the index scan, and table access mode, it's using analyzed of employees and with a row id, and the all rows is the optimizer mode, which is using in the optimal way, correct. So this is what it is. And the final part is the SQL ID. So the part of this TKPROF output, right? Like you will see the SQL ID as a information. This is something we can go and check it out in the $SQL and check it out which query it belongs to when the session is active. Okay. And the plan hash is zero, so which means like when you are manually using it, the value will be zero. So this is what it is. Yeah, so you can check it out, like I mentioned, this based with the SQL ID. When the session is active, you can go and check it out which query it belongs to, okay. And finally, the summary behind this discussion is like for this particular scenario, right, like since the index is already been used, it's effective and it's good in shape, okay. And whether the input output operation is using disk, no. So zero disk reads, so it's really efficient, and four logical reads which is from the memory, that's also good. And there is no CPUs involved. So for more RAM operations. And finally, the row counts returned as expected with one rows returned. Okay, and optimizer mode, which we discussed, good for throughput, correct? Like it's in the volume. Yeah. So the final goal we achieved, like there is no tuning is required since it's already in a better optimal way, correct. But only one caveat or exception we call it is like instead of hard coding unread, which is misses the cache, correct. Like that is the only caveat, like we can introduce the binding variable instead of that. Otherwise this query is since the index already been there, like it's giving the optimal results, we no need to touch anything. So this is how this TKPROF diagnostic tool can be used it to see the slow running query to optimize the query. In this case we are checking for the optimized query, but this is really good in shape, like we don't have to touch it. Like in case of the complex query or slow running query, all those things, like we can check it out, the reason behind whether the index is missing or the data statistics is missing, and so many different options we can check it out through the plan summary information, okay. The same way, this approach, if you follow this sequence of action, you should be good, okay. Hope this video really good for useful for you. If there is any questions or concerns, like let me know. I'm happy to help you to answer your questions. Thank you.